Hello and welcome to this video. In this video, we will solve the first set of problems on complex numbers. So if you are following my video recording, then you will know that in one set I solve only 10 problems. So first 40-50 problems will be very easy and I'll quickly go through them. So as always, I say that you should pause the video when I am presenting the problem and try to solve them yourself. If you cannot solve them yourself, then you should look at the solution. With that out of the door, let's get started. So problem first is a set of 4 problems. We have to evaluate I to the power 5, I to the power 67, I to the power minus 49, and I to the power 2014. So I to the power 5 can be written as I to the power 4 into I to the power 4 is 1, so it is 1 into I, which is I. I to the power 67 is I to the power 64 into I cube. I to the power 64 is 4 into 16, that it is a multiple of I to the power 4. So it will become 1 to the power 16. This dot is product sign, and I cube is minus I, so it will be minus I. I to the power minus 49 can be written as 1 by I to the power 49, then it is I to the power 48 into I. 48 is multiple of 4, so this will become 1, and so the end result would be 1 by I, which is equal to minus I to the power 2014 can be written as I to the power 2 in 2007. This is a typing mistake, so the power is not proper. So I square is minus 1 to the power 1007, which is minus 1 because it is odd power. So minus 1 will be to the power odd number is minus 1. Problem number 2 asks us to prove that if A is less than 0 and B is greater than 0, then square root of AB is equal to square root of mod A into BI. So we know that if A is less than 0, then A will be equal to minus of mod A. So it requires the definition that mod of a positive number is positive, that is the number. So mod of x is x if x is greater than 0. If it is 0, that is mod of x is equal to 0 if x is 0. But if x is less than 0, then modulus of x will be minus of mod x. Mod x means magnitude. It does not include sign. So it is always positive. So for negative values, you have to apply minus sign to the mod for equality. So square root of AB becomes square root of minus of mod of A into B. Minus is equal to I square, so I comes out, and it is equal to square root of mod of A into B, I. This I is outside square root. Prove that I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3 is equal to 0. So we take I in common here. What is inside brackets is 1 plus I square plus I cube. I square is minus 1. This should be a plus sign. The typing mistake. So I square is minus 1 and I cube is minus I. I gets cancelled. 1 gets cancelled. So the term inside brackets gives us 0. So I to the power n into 0 is equal to 0. Problem 4 says that find the value of the sum from n is equal to 1 to 13. And in brackets, we have I to the power n plus I to the power n plus 1. So we expand this and we write I plus I square up to I to the power 13 plus I square. This should be a plus also. I cube up to I to the power 14. So you know that sum of any 4 consecutive powers of I will be 0. So I square to I 13 forms 12 such consecutive powers. So this is a multiple of 4. 12 is multiple of 4. So these 12 will become 0. So only I will remain. In this case, we take out I square and I to the power 13 to I to the power 14 will become 0. So I square is minus 1. So the sum is I minus 1. Problem 5 says that simplify and find the value of 2 to the power n divided by 1 plus I square. This is to the power 2n, and this is 1 plus I square to the power 2n divided by 2 to the power n. These n have not come at appropriate place. So what we do is we square the 1 plus I. So we get 1 plus 2i plus I square, and then power n is there. 1 and I square will get cancelled because I square is minus 1. So what we get is 2 to the power n by 2 to the power n to I to the power 2n, and 2 to the power n into I to the power 2n divided by 2n. So 2n will get cancelled in both the fractions, and what we will have is 1 by minus I to the power n plus minus 1 to the power n, because this should be minus 1. This is not minus I. This is minus 1. I square is minus 1, so it will be minus 1 to the power n. Problem 6 says that find the different values of I to the power n plus I to the power n where n is in set of integers. So we let s to be the sum, which is equal to I to the power 2n plus 1 by I to the power n. It has come because if we represent I to the power minus n in fractional terms, it would be 1 by I to the power n. Then we multiply, take LCM and multiply, it becomes I to the power 2n plus 1 by I to the power n. Now we substitute n is equal to 1, we get I square plus 1 by I, which is 0. We substitute 2, we get I to the power 4 plus 1 by I square, which is minus 2, because I to the power 4 is 1 and I square is minus 1. For n is equal to 3, it becomes I to the power 6 plus 1 by I cube. I to the power 6 is I square, which is minus 1, it becomes 0 again. For n is equal to 4, we get 2. So you see that we get 3 different values, 2, 0 and minus 2 for the sum. So that's what is our answer. Problem 7 says that if 4x plus 3x minus y into I is equal to 3 minus 6i, then find the value of x and y. So we compare real and imaginary parts. We get 4x is equal to 3 because 4x is here and 3 is here. Both are real parts. And similarly, 3x minus y is equal to minus 6. So from this, we get x is equal to 3 by 4. We substitute here. We get 9 by 4. So bring 6 this side, y this side. So 9 by 4 plus 6. We take LCM. 6 4 they are 24. 24 plus 9 33. 33 by 4 is the value of y. Problem 8 says that find the value of 1 by 3 plus I 7 by 3 plus 4 plus I 1 by 3 minus of 4 by 3 plus I. So we sum the real parts in one bracket and we sum the imaginary parts in another. We get 1 by 3 plus 4 by 3. We take LCM. So 4 into 3 is 12. 12 plus 4, 16. 1, 17 by 3. And I would be 7 by 3 plus 1 by 3 minus 1. So LCM would be minus 3 here. So 7 plus 1, 8 minus 3 is 5. 5 by 3 is our answer. Problem 9 says that find the real value of x and y if 1 plus I into x minus 2i by 3 plus I plus 2 minus 3 into I, 3i into y plus I by 3 minus I is equal to I. So in this case, we take LCM. Our left hand side becomes 1 plus I into 3 minus I into x plus, minus. No, this should be, this is minus 2i into 3 minus I, and then we have the second term as 2 minus 3i into 3 plus iy plus 3 plus I into I, and with the denominator we take to the right hand side. So right hand side becomes I into 3 plus I into 3 minus I. Now you observe that 3 plus I and 3 plus 3 minus I are conjugate of each other. So product will be x square plus y square, that is 3 square plus 1 square, which is 10. And this, after multiplication and simplification, we get 4x plus 9y minus 3 as the real part and I into 2x minus 7y minus 3 as the imaginary part. So real part is 0 on right hand side. So we can write that 4x plus 9y minus 3 is equal to 0. And imaginary part we can write as 2x minus 7y minus 3 is equal to 10. So now we have two linear equations in x and y which you can solve to get x as 3 and y is equal to minus 1. So if you want to verify, we substitute x is equal to 3 here, 12, and y is minus 1. So minus 9, 12 minus 9 is 3, 3 minus 3 is 0. In this equation, 3 to the 6 and plus 7 here from minus 1. So 6, 7, 13 and 13 minus 3 is 10. So yes, this solution is correct. Problem 10 says that find the multiplicative inverse of 4 minus 3i. We let the multiplicative inverse to be 1 by z, where z is 4 minus 3i. So 1 by z is equal to 1 by 4 minus 3i. Now we want to get rid of imaginary part in denominator. So one of the easy ways is to multiply it with its conjugate. So we multiply and divide with conjugate. 4 plus 3i So our denominator becomes 4 square plus 3 square, that is 16, plus 9, that is 25. And the multiplicative inverse is 4 plus 3i by 25. So with this, we have solved 10 very easy problems. And in my next video, we will solve 10 more easy problems. So stay tuned for the next video. And if you have found this video useful and informative, please subscribe to the channel and like the video so that it can reach many more students like you and they can also benefit from this video. Thanks a lot for watching the video. Enjoy.